Hello again. Several of you emailed me about the answer to problems 2 and 3 is related to it on homework 1 for chapter 8. The question reads, a .45 kilogram baseball is thrown toward a batter with a velocity of 41 meters per second and hit back toward the pitcher at 35 meters per second. What was the change in momentum? Many of you asked me, why did I add the velocities to get the change in momentum? Well, I didn't. I subtracted the velocities. The change in velocity is always the final minus the initial velocity. But let's look at the situation. The pitcher throws the ball toward the batter. The batter hits the ball in the other direction toward the pitcher. We must give one of those values a negative sign because one direction is clearly opposite to the other. So one has to be positive, the other negative. I chose to make toward the batter negative. So I called the 41 negative. So I made a list. Initial velocity is negative 41. Final is 35. The change in velocity, again, is the final minus the initial. So 35 minus a minus 41. That subtraction gives you 76. You might argue, well, you did kind of add them because a minus, but please, I didn't. It's a subtraction issue. So the change in velocity is 76. The change in momentum, delta P, is mass times delta V. Mass times change in velocity. So I plugged in my values, get 34.2, rounds to 34 kilogram meters per second, the unit for momentum. A quick note though, think about it. If the ball is going 41 and you stopped it, that would be a change in 41 right by itself. And then you send it going in the other direction, 35. That is a total change of 76. For question 3, we were given the time and asked to find the force. And of course, if we know the time and we know the change in momentum, we can solve the impulse momentum theorem for force. And we get force equals change in momentum over time. The change in momentum again was 76 kilogram meters per second, and the time was given to be 3.1 times 10 to the minus 3 seconds. Now that's really just 0.0031, and the answer comes out to be 11,032 newtons, or for 2 sig figs, 11,000 newtons.